Okay, so we've got another group exercise here, and it's a little bit of a review in terms of naming and looking at different isomers, both linkage or structural isomers, the constitutional isomers, and diastereomers are an example of stereoisomers. And so let's go ahead and just dive in on this first one here and take a look. And what we're going to do is say, okay, well, we've got a naming problem here, and oh, there's a lot of ligands there. Wow. Okay. We've got this vanadium complex, and we've got some ethylene diamine, right? And the ethylene diamine is zero charge. I always like to just do a quick inventory of our ligands and what the charges are. We've got the thiocyanate, thiocyanato ligand here. That's going to be a -1, right? And then chloro is always a -1. And then we've got the perchlorate counterion, which is not bound to the metal, and that means the complex then has to be overall 1+, right? So if that's the case, then we've got 2 negative total, and that means that vanadium has to be a 3+. So that way a 3+ plus 2 anions gives you a +1 left over, which is balanced by the perchlorate. So good. We can check this out now. We see that the complex is actually a cation, right? So that's important in our naming. So let's look at this. We've got a bunch of different ligands here. So alphabetically, let's start with chloro. There's only one chloro, so we're going to say this is chloro. Our next one in alphabetical order would be the ethylene diamine, and remember that's a bidentate ligand, so we're going to use a special prefix bis, ethylene diamine, and that's important to try to spell this correctly, really important. And then finally the thiocyanate ligand, because we're bound through the sulfur, so this is going to be thiocyanato. And then we're going to name the metal. It's cationic, so we do not add ATE, so this is just going to be vanadium. And the oxidation state is 3. And then finally we put our counterion, in this case, which is perchlorate. So that's kind of a mouthful. You've got chloro, bis, ethylene diamine, thiocyanato, vanadium 3, perchlorate. So a little review there for nomenclature. The next one says draw and name 2 linkage isomers, and this is important, right? Linkage isomers deal with the way certain ligands will bond to the metal, and we will need to look at our Lewis structure here for our NO2-, right? So we've got this guy here, and we've got an oxygen over here, and a lone pair on the nitrogen, so we can bond through there, or we can bond through a lone pair on the oxygen. So there's 2 different configurations, 2 different connectivity changes or options, which means this is a constitutional isomer, right? And specifically a linkage isomer. So let's go ahead and look at what we have here. We've got a chromium complex with 5 chloros and 1 NO2, and they're all negative charges, so it's going to be a 6- for our ligand count. And then if there's 6- in ligands, we know this whole thing is going to be a -3, right, because it's balanced out by the 3 ammonium ions. This means that the chromium then is a 3+. So we go ahead and throw that guy in there, and let's mark the charge there. Again, I typically put, when I'm drawing my octahedral, which this is an example of, I draw 4 in the plane of the paper, and I draw my dotted wedge out and my filled wedge up towards me here. And so let's just go ahead and put on all those chloros. There's quite a few of them. And then we've got 1 spot left for the nitro. In this case, I'm going to bond it through the N, which is indeed the configuration that we call nitro. Again, we want to make sure to put the overall charge on the complex, and there we go. Do the same thing over here to get our other option. We're going to do our dashed wedge right here, our filled wedge, and then 1, 2, 3, 4. I'm just going to do the same thing here. Put all these chloros around here, and then finally, in this case, I'm going to bind it through the oxygen, rather, and this is going to be called nitrito. So there you go, an example of 2 linkage isomers. And now this one wants us to go a little bit further and then write the name. So in this case, we just do our typical example. So we say this is an anionic complex, so that means we need to put the positive counterion up front. So we'll say this is ammonium, and that is not bound directly to the metal. And then alphabetically we name our ligands. So there's 5 chloros. So this is pentachloro, and our next ligand in this case would be our nitro. So pentachloronitro, And since this is a anion, we have to put ATE at the end of the metal name. This is chromate, and we still put our oxidation state. So ammonium pentachloronitrochromate. So that's this one here. And if we were going to name this one, we can call it again ammonium. Again, pentachloro. And in this case, it's nitrito because it's bound through the oxygen, but that doesn't change anything else. So there we go. We've got ammonium pentachloronitrito chromate 3. Pretty simple, not too hard. And we'll go ahead and go to our last one here. This one's looking for diastereomers, right? So these are going to be examples of stereoisomers, right? So we've got our platinum here, and we've got two different arrangements here, and this is going to be a platinum square planar. So we're going to have our platinum here. This is a 2+, right? Because the whole thing's neutral, and so we're balancing out the -2 from the 2 chloros, so we get 2+ there. And if this is a square planar, we just put everything in the plane of the paper. And we have two different options here. We can put the 2 chloros next to each other, right? That's going to be 9 degrees apart. And the 2 amines next to each other. So there we go. This is what we call a cis arrangement, 9 degrees apart. And then we can come over here and we can take the other option, and we can say we put the 2 chloros 180 degrees from each other. Same thing with the 2 amines rather. Good. And this is going to be our trans. So now we will name this the same way, except that we'll put cis or trans in front of it. So I'll just go ahead and name this one over here first. So we'll say this is our cis isomer, and then we put that in front of everything else, and we say this is going to be diamine. Note the spelling there. Dichloro platinum 2. And then for this one, same thing. We just say that's trans dichloro. Oops, messed up there. Be careful. Don't want to get too complacent and make a stupid mistake like that. And remember, we want to keep alphabetical order. So diamine. Sorry about that. I got in a hurry trying to get this done so I can go get some dinner. Diamine dichloro, just like the previous example, right? And then platinum 2. So there we go. And so the cis and trans prefixes just go out in front of the name, and you name it just like you would name it any other complex. So there you go. Pretty simple. Sorry about the hiccup there, getting a little bit in a hurry, but it's all good in the end. So there we go.